So last week we were talking about taking and finding derivatives. This one's just for the power functions, which means we're just looking at different functions. So, just as a reminder first before we get started, if f of x is equal to a x to the power of n, how do we find the derivative? What do? A times n times x, n minus 1. So remember, you take the power down, you multiply it, then you just subtract the power by 1. Okay? It's nothing too difficult. Now, all of these are exactly the same. You just have to do one bit of manipulation first before you do it. So, just to remind you of some of the rules to help you manipulate it. If you have a 8th root, I guess, and to the power b, how would you write this out as a fractional power? Anyone remember? See this bit? That bit goes on the bottom of a fraction, and then whatever power you have there goes on the top. Okay? Okay. Now if you have a fraction, not a fractional power, a fraction, what do you do to the power? I knew you guys would forget, that's why I'm reminding you. Yay! Someone remembered. You make it a negative. Now if you think about it, it should make sense. It's a minus because you're going to divide it. Remember your index laws, how if you're doing x to the power of b over x to the power of a, you subtract the powers. That means this bit just becomes a negative. Okay? Same reason. This one's the same. If you think about it, if you had square root of x to the power of 4, you're really dividing that by 2 because this technically has a 2 on top. So that becomes 4 divided by 2, which gives you x to the power of 2. Okay? Alright, and last bit, here's a complicated one. It's not that complicated. This is the same as the one above. What do I just need to put in front of it? Minus. Yes, very good. Okay, any questions so far? Now, let's do some examples. If you have one x to the power 3, whoops, what do I put on the top? Three? Is this a fraction one? Or is this a negative one? Yes, it's a fraction. Okay? If you're not entirely sure that, like I said, we don't write it, but that technically has a 2 on it. We just don't write it because normally we have, it pops up very often. This one, the bottom's already a fraction for you. So what do we need to do to it? Minus. Yep. Fairly straightforward. You just put the minus in front. And then if you have multiple things on there, this is my suggestion to you. Write those numbers out separately as a fraction. Then you just put everything on the x separately, like that. Now, there was a fraction here that's on the bottom of a fraction, so put a negative. What's a power here? 1. What's this 1 over? 3. Good. Okay? Any questions so far? Anyone need a moment to think about it? Anyone absolutely confused? Now, once you've done that, then we can find the derivatives. So, just keep all the rules in mind. And here's our function. Now what we need to do, remember how I said you can break up each of these fractions separately? Do that first. So you have 2 over 2x cubed. I know you can simplify some of them, but we'll just leave that for now. Okay? Once you've done that, then go and simplify your numbers. So you have a 2 and a 2. 2 goes into both, so you're left with a 1. This one you can't do anything about, except for the x squared and the x cubed. So if there's 2 here and there's 3 here, what am I left with? How many on the bottom? One of them, right? And then same here, 8 and 2. 2 goes into 8 4 times. And then there's a 5 and a 3. So 5 minus 3 gives us a what? 2. So now let's write it out. 1 over x cubed plus 1 over 2x minus 4x squared. Now do the step before first, before you do the derivative. When you're used to it, sure, you can just jump straight ahead and do it, that's fine. But if you're not sure about it, do the step where you manipulate it first. This one, you put the fraction, that's a negative, so it's -1. The reason for us doing it first is this. When you do your derivative, it's still the exact same rule as before, but once we've actually moved it, we can just do what we were doing before, right? So you take the power down, that becomes a -3. You subtract that power by 1, so that becomes a -4. Same with this one, you take that power down, that becomes a -1 times a half. Then this part becomes a -2. This one's the same as before, so I shouldn't need to go through that one. So then, once you've done all of that, simplify it down. Like so. However, depending on what the question asks you, you may want to consider rewriting that. So if it says you need to write in positive integers, then make sure you change all of your fractions, all of your negatives into positives. Okay? If you were to do that, remember that's a fraction, so you just take the x down. Same with this. Like so. Any questions? Janelle seems really confused and needs to rewatch this. Alright, last bit, state its domain. Now, we talked about maximal domain before, that was probably a long time ago, so I'll give you a refresher. Just check this one here. What values can't you have? Or this one really, either one will do. What values can't you have on the bottom? 0. So that means it's x is an element of all the real numbers except 0. Any questions? It looks slightly confusing. I'm sure once you do it, you'll get it. It's a lot more straightforward than it looks right now. Alright, so if you have this one, and we want to find f dash of x, do we start doing it straight away? No, we want to make it simpler for ourselves first, right? So let's just fix this. We have 2 and a root 3. Remember, separate your numbers, times, and then this is the square root of x, so that becomes a half. Then f dash of x would be, that number stays there. You take that number down, then you subtract it by 1, so you should get -1/2. Then simplify your numbers. Alright, now it says, actually I should rewrite this first. So there's a negative, puts it on the bottom of a fraction. there's a to the power of a half, so it's square root of x. And then what's its domain? What's the domain for this one? Same thing here. What can't we have? 0. So all real numbers except for 0. Alright. Calculate the gradient of a tangent at the point where x is equal to 3. Just sub it in again. Whoops. Try that again. So root 3 over root 3, what does that give us if it's the same? 1.